Hi everyone. Today we're going to study union and intersection of sets. Let's begin with union of sets. The union of two sets is the set of elements that belong to either of the two sets. Given two sets A and B, the union is given by the symbol. This U here is the symbol for union. So we read this as A union B. And the elements of this A union B is the variable x, such that x is an element of set A or x is an element of set B. Using Venn diagram, this is the illustration for the union of two sets. The A union B is the shaded part. We can see that the whole set A and the whole set B are shaded. We have a notes here regarding cardinality of union of sets. First, the cardinality of A union B is this formula. Cardinality of A plus cardinality of B minus the cardinality of A intersect B. Number 2, the cardinality of the union of three sets. Let's say A union B union C. And the formula is this: cardinality of A plus cardinality of B plus cardinality of C minus cardinality of A intersect B minus cardinality of B intersect C minus cardinality of A intersect C plus cardinality of A intersect B intersect C. Let us see this example. If set A equals 0, 2, 7 elements and set B equals 1, 3, 7 and 12 elements, find the cardinality of A union B. First, let us write A union B. Let us write all the elements of sets A and B together. If there is repetition of elements, we will just write it only once. So the elements are 0, 1, 2, 3, 7, and 12. We say that the cardinality of A union B equals 6 because there are 6 elements in the set A union B. For the cardinality of A, this is equal to 3. There are 3 elements in the set A. The cardinality of B equals 4. There are 4 elements in the set B. The A intersect B equals 7. We can see that the element 7 is common to both A and B. So the cardinality of A intersect B equals 1. There's only one element in the set A intersect B. Now for the formula of cardinality of A union B, this is the formula. We're going to substitute the values from this column. So the cardinality of A is 3 plus cardinality of B is 4 minus cardinality of A intersect B, which is 1. So we have 3 plus 4 minus 1, total is 6. This is the final answer. Let us now discuss intersection of sets. The intersection of two sets is the set of common elements of the two sets. Given two sets A and B, the intersection is given by the symbol. This inverted U is the symbol for intersection. So we read this as A intersect B. The elements is the variable x, such that x is an element of A and x is an element of B. Using Venn diagram, this is our illustration. We have the set A and set B, and we say that the A intersect B is this shaded part. Let us see this example. If set A equals 0, 2, 7 elements, and B equals 1, 3, 7, and 12 elements, find A intersect B. We can see that the common element for A and B is that number 7. So we write it here. So this is the final answer. There is a note. If there is no common element between two sets, then the intersection is a null set. Today we're going to study disjoint sets and complement of a set. Let's begin with disjoint sets. Two sets are said to be disjoint if their intersection is the empty set. Note that if A and B are disjoint sets, then the cardinality of A union B equals cardinality of A plus cardinality of B. Remember that cardinality means the number of elements in the set. For example, we have set A equals 0, 2, and 7 elements, and set B equals 1, 3, 5, and 12 elements. We can observe that there is no common element to both sets. So if we write A intersect B, the answer is a null set or empty set. And we say that the sets A and B are disjoint sets. Let's discuss complement of a set. The complement of a set is the set of elements in the universal set that do not belong to a given set. Given set A, the complement of a set is given by the symbol A bar, and the elements of A bar is the variable x as an element of universal set, such that x is not an element of A. This A bar is also represented as A raised to C. Given this Venn diagram, the set A is here in the middle and the shaded part is the A complement. Now let's have example. Let the universal set equals the numbers from 1 to 10, and set A equals 1, 4, 7, and 10 elements. Take note that A here is a subset of the universal set. If we write now the A complement, we're going to write all the elements of the universal set that do not belong to the set A. So the elements are 2, 3, 5, 6, 8, and 9. This is the final answer. Today we're going to study difference, and symmetric difference of sets. Let's begin with difference of sets. The difference, or sometimes called relative complement, of two sets is the set of elements that belong to the first set but not to the second set. Given sets A and B, the difference of two sets is A minus B, and the elements are the variable x, such that x is an element of set A and x is not an element of set B. To illustrate, we have the figures here. The sets A and B are described respectively, and the A minus B is the shaded part here. For example, let set A equals 0, 2, 3, 6, 7, and 10 elements, and set B has elements 1, 3, 7, and 12. For A minus B, the elements are all elements of set A that do not belong to set B. So the elements are 0, 2, 6, and 10. This is the final answer. Let us now discuss symmetric difference of sets. The symmetric difference of two sets is the set of elements that belong to either one or the other set, but not to both. The symbol is A delta B. The elements are the variable x, such that x is an element of A, exclusive or x is an element of B. Sometimes this A delta B is represented by the symbol A XOR B. The set builder is this. The A XOR B equals the element x such that x is an element of A union B and x is not an element of A intersect B. To illustrate, we have the sets A and B in here. The A XOR B is the shaded part. Let's see this example. Let's set A equals 0, 2, 3, 6, 7, and 10. And set B equals the elements 1, 3, 7, and 12. Let us now get the symmetric difference. So we have A delta B, or we can write that A XOR B. Let us observe that the two sets A and B have two common elements, and those are the 3 and 7 respectively. For our answer, we're going to write all the elements of A and B combined except those common elements. So the elements of A delta B equals 0, 1, 2, 6, 10, and 12. This is the final answer. Today, we're going to study Cartesian product. Let A and B be two sets. The Cartesian product of A and B, denoted by A times B, is the set of all ordered pairs AB, where A is an element of set A and B is an element of set B. By set builder notation, it will be like this. A times B equals the ordered pair AB such that A is an element of set A and B is an element of set B. Let us see this example. Let set A has elements A and B, and set B has elements 1, 2, and 3. Find the Cartesian product of A and B. So our A times B equals the ordered pair AB such that A is an element of set A and B is an element of set B. So the answer is like this. The first element is A1, second is A2, third is A3, fourth is B1, fifth is B2, the last is B3. So we take the first element from set A and the second element coming from set B. There are notes here. Number 1, the ordered pair AB is different from the ordered pair BA. The Cartesian products A times B and B times A are not equal unless A is an empty set or B is an empty set, so that A times B equals B times A equals empty set, or it can be A equals B. So this is our final answer here. Let us define ordered n-tuple. The ordered n-tuple A sub 1, A sub 2, up to A sub n is the ordered collection that has A sub 1 as its first element, A sub 2 as its second element, and A sub n as its nth element. In connection to this, we're going to study Cartesian product of the sets A sub 1, A sub 2, A sub 3, up to A sub n on that order. The Cartesian product of the sets A sub 1, A sub 2, A sub 3, up to A sub n, denoted by A sub 1 times A sub 2 times A sub 3 times up to A sub n, is the set of ordered n-tuples A sub 1, A sub 2, A sub 3, up to A sub n, where A sub I is an element of the set A sub I, for I equals 1, 2, 3, up to n. By set builder notation, we will write like this. Let us see this example. Let set A equals A, B. Let set B equals 0, 1, and 2. And set C equals alpha. Find the Cartesian product of A, B, and C. So we have three sets here, and we write A times B times C. And the elements will be of this form: A, B, C, such that A is an element of set A, B is an element of set B, C is an element of set C. So for our Cartesian product, the elements are here. The first is A0 alpha, second A1 alpha, third A2 alpha, fourth B0 alpha, fifth B1 alpha, and the last B2 alpha. This is the final answer. There is a remark here with regard to cardinality of the Cartesian product. So we read, the cardinality of a sub 1 times a sub 2 times a sub 3 times up to a sub n equals cardinality of a sub 1 times cardinality of a sub 2 times cardinality of a sub 3 times up to the cardinality of the last set, a sub n. Remember that cardinality means the number of elements in a set. In our example here, the cardinality of A times B times C equals cardinality of A times cardinality of B times cardinality of C. Putting the corresponding values, we have 2 times 3 times 1. Cardinality of A is 2, as we see that there are 2 elements in set A. Cardinality of B is 3. There are 3 elements in set B. Cardinality of C is 1. There's only 1 element in set C. So 2 times 3 times 1 equals 6. We can count the number of elements in this Cartesian product. 1, 2, 3, 4, 5, and 6. Today we're going to study set identities. Given the universal set U and the sets A, B, and C. The first identity is commutative loss. It says A union B equals B union A. Also, A intersect B equals B intersect A. Number 2, associative loss. The first is A union the operation B union C equals the operation A union B union C. Also, A intersect the operation B intersect C equals the operation A intersect B intersect C. Third is distributive loss. Number 1, A union the operation B intersect C equals the operation A union B intersect the operation A union C. Also, A intersect the operation B union C equals the operation A intersect B union the operation A intersect C. Number 4 is identity loss. It says A union a null set equals the set A. Also, A intersect the universal set equals the set A. Number 5 is complement loss. In here, there are many identities. The first is the complement of set A equals set A. Next, A union the complement of A equals the universal set, the U. Third, A intersect the complement of A equals null set. The complement of the null set equals the universal set. The complement of universal set equals the null set. Number 6 is idempotent laws. We say that A union A equals A. A intersect A equals A. Number 7 is universal bound laws. A union universal set equals universal set. A intersect a null set equals a null set. Number 8 is De Morgan's laws. The complement of the operation A union B equals the complement of A intersect the complement of B. The complement of the operation A intersect B equals the complement of A union the complement of B. Number 9 is absorption laws. A union the operation A intersect B equals A. A intersect the operation A union B equals A. Number 10 is the difference law. It says A minus B equals A intersect the complement of B. I hope you learned something from this video. See you again next time.